Assalamu alaikum and Bismillahir Rahmanir Rahim. Welcome to our YouTube channel Paper World, in which we are solving topicals for IGCSE Physics 0625, and at the moment we are doing P2. We've already covered the topics of length and time, um, scalar and vector, and motion. Now we are starting our fourth topic, which is mass and weight. So before we start, just hit the bell icon and hit subscribe button and like button so that you guys don't miss any videos. All right, let's begin. Mass and weight. Question number one. Which two quantities must be known to determine the density of the material? Okay. The formula for density is equal to mass per volume. So it would be B option. Question number two says that on the earth, a spring stretches by 5 centimeter when a mass of 3 kgs is suspended from one end. KG, there is something wrong with my stylus. Let me. Okay, question 2 states that on the earth, a spring stretches by 5 centimeter when a mass of 3 kgs is suspended from one end. The gravitational field strength on moon is 1/6 of that on the earth. Which mass on the moon would stretch the spring by the same extensions? And then a few values are given. Okay, first of all, the situation is that a spring stretches to 5 centimeter, ठीक है जी, when a mass of 3 kgs is suspended from it. ठीक हो गया? Now we have to see that which mass on the moon would stretch the spring by the same extension. Okay. We should first find out the weight of this object. ठीक है? W is equal to mg. That's the formula with which mass and weight are correlated. Weight is to be found in 3 and 10. Acha, I am taking the value of g to be 10 because before 2025, the kids who have to get papers in 2025, the value of g was taken to be 10. ठीक है? Up it's taken to be 9.8. So there would be a difference, minor difference in the answer if I take 9.8 as the value for this question, as it was understood and taken as 10. Okay, so I am taking this to be 10. In the new questions, we will solve them by taking the value of g to be 9.8. ठीक है जी? अच्छा जी, 30 न्यूटन्स आपका हो गया इस चीज का, इसी ऑब्जेक्ट का weight. ठीक है? Now we know and we've been told that on moon, the gravitational field strength is 1/6 of that of Earth. So just write it here. On moon, 1/6 of 10, obviously, because 10 is on Earth. ठीक है? So we will find a value of g. ठीक है? Because it's 1/6 of that, what is it on Earth? So it would be 3 and 5. So it would be 5/3. ठीक है? On moon, the gravitational field strength would be 5/3. ठीक है जी? Now जी, moving forward, we know that the weight we found out to be 30 newtons. ठीक है? Mass we have to find, and we know that the value of this is 5/3, or you can also do it in decimal. So 30 into 3 is equal to m and 5. 33s are 90 and 5, and m would be 5 by 3. ठीक है? 5 by 3 is 90. 5 by 3 is 120. 120 divided by 5 is 100. 100 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 divided by 5 is 100. 90 over 5, which is 30. ठीक हो गया जी? It's not 30, 5 1 5, 5, 5, 6, 5, 8 are 40. So it comes out to be 18 kgs. Okay, so we've reached our answer. Okay, a shopkeeper pours rice into a dish that hangs from a spring balance. It records the reading. A customer buys some pasta. The shopkeeper notices that the reading on the spring balance with just pasta in the dish is the same as it was with the rice in the dish. Which quantity must be the same for rice and pasta? Now we know that a spring balances actually is related to finding the weight of an object. So density isn't measured by a spring balance, temperature isn't measured by a spring balance, volume isn't measured by a spring balance, so T is weight. ठीक है जी? Which statement about a falling object accelerating close to Earth's surface is correct? The weight of the object is increasing and the force of air resistance on the object is decreasing. Okay. The weight of the object and the force of air resistance on the object are equal or of equal magnitude but act in the opposite direction. Okay. The weight of the object is constant but the force of air resistance on the object is increasing. The weight of the object is less than the force of resistance. Achha, we need to see that what is happening over here. We've established the fact that the main force that acts on the object is its weight due to gravity, of course, which can be constant as the object is near Earth's surface. ठीक है? As the object falls, its speed increases. ठीक है ना? So the air resistance, which is the opposing force, will also increase. If the speed is increasing, then the air resistance, which is the opposite force, would also increase. ठीक है जी? So the answer to it is that the weight of the object is constant, but the air resistance on the object is increasing. Why is it happening? I've just told you that uh, the main force of gravity that's acting on the object is its weight due to gravity, which is constant, and as the speed is increasing, so air resistance is also increasing. Okay. Question number 5. Should I explain these two options as well? I've already explained, so चलो आगे चलते हैं. Two rectangular blocks consist of different materials. 4 different methods are suggested to compare the two masses. Acha, we have to compare masses. Now remember that. Compare the acceleration with which they free fall. Compare the values of their lengths, breadths, and heights. Okay. Hang each in turn from the same spring, compare the extension. Okay. And place one on the right hand pan of the beam balance and the other on the left. ठीक है? अच्छा, the answer for it is D. If we compare the acceleration with which they fall freely, तो acceleration would be constant. ठीक है जी? So this doesn't account for comparing. Comparing the lengths, breadths, and height would give you volume, and that won't be comparing the masses. ठीक है? Hanging each from the spring, a spring balance measures weight or compares weights. So this can't be it. So D is the only option, that place one on the right hand pan of the beam balance and the other on the right hand, or the difference, one of them will tilt downwards and one will stay upwards because there is a difference in their masses. So that is how you can compare them. Okay, which one is heavier and which one is lighter. Okay, question number 6. A rectangular swimming pool is 50 meters long and 25 meters wide. Okay, it contains water at a depth of 2 meters. The density of the water is 100 kg per meter cube. What is the mass of the water in the pool? Okay, so to find out the mass, we need, there are a few formulas which can be used. Okay, one I've told you, W is equal to mg, but here the weight is not there, so the mass can't be taken out. The other which formula that can give us mass is density is equal to mass per volume, since the density has been mentioned over here in the question. So we can use this formula to measure the mass. Okay, so density we know is 1000. Mass we have to find out, and we don't know anything about volume, but we know that the swimming pool is 50 meters long and 25 meters wide, and we also know the depth. So we have the three dimensions or values that we need, length, width, and depth, that we need to find out the volume, because volume is equal to length into width into height. ठीक है जी? तो 50 into 25 into 2 would give us 2500. So now we have the volume. We will write the density. Volume would be 2500. So 2500 into 1000 is going to be our mass. So it is 25, 1, 2, 1, 2, 3, okay, kgs. This is going to be our answer. Here it is. ठीक है, नॉर्मली तो अभी हम वेट और मैथ्स के क्वेश्चंस कर रहे हैं और ये फॉर्मूला सबसे ज़्यादा इस्तेमाल होगा, बट ऑब्वियसली वील हैव टू look into other formulas as well to find or solve this question. It would be covered amply in the density part, but since it's here, so I've just solved this question. Okay, question number 7. An object in space probe above the Earth weighs 3.5 newtons. The gravitational field strength at the height of the space probe is 7 newton per kg. The gravitational field strength on the Earth's surface is 9.8 newton per kg. What is the mass and weight of the object on the Earth's surface? Okay. Now we know that something has a weight of this. ठीक है? When the gravitational force strength is 7. ठीक है? So we can find our mass with the help of these two values. ठीक है? And we know that the mass anywhere would be the same. ठीक है? वो Earth की surface पे हो, Moon पे हो, Mars पे हो, Venus पे हो, it would be the same. So in order to solve what is the mass and weight of the object on the Earth's surface, we have no other value other than the value of g. So we need something else, because matlab we have to have at least two values na to find the third value. तो वो जो value है हम mass की निकाल लेते हैं from these two values, क्योंकि the object is the same. ठीक है? तो हम उसका weight use करते हैं 3.5 newtons, और उसको यूज करके हम मास निकाल लेते हैं. उसका वेट 3.5 न्यूटन्स तब है जब द ग्रेविटेशनल फील्ड स्ट्रेंथ इज 7 न्यूटन्स पर केजी. ठीक है जी? तो 3.5 divided by 7, the mass would be 0.5 kgs. ठीक है? Now we have the mass of the object. ठीक है? Now we can see that what will be the mass of the object and weight of this object, which was somewhere near अच्छा space probe पे था. उसका क्या mass और weight है. तो हमें ये तो पता चल गया कि हमारा mass kgs में आया हुआ है 0.50. So ये तो options eliminate हो गई. Now we are going to find the weight and see which option out of A or B is correct. So we will write W is equal to mg. W is equal to m is 0.5 kgs, and here on earth the value of g was 9.8 newtons per kg. So it means that it is going to be 0.5 into 9.8, 4.9 newtons. So B is our correct option. This was space probe. Forgot to write it. So I hope you got the question. Acha ji, the diagram shows 4 pieces of laboratory apparatus. Which piece of apparatus is used to find the density of the heat? Okay, we've just done the formula for density, which is density is equal to mass per volume. So we will need something to measure the mass and something to measure the volume. Okay? So mass can be measured by a balance and volume can be measured by a measuring cylinder. Ruler is of no use over here, and stopwatch measures time. It has nothing to do with density. Okay? So we need to have an option which covers this. B is the option. Balance and measuring cylinder. Okay, ji? Okay. The diagram shows the dimensions of a solid rectangular block of metal of mass m. Okay. Which expression is used to calculate the density of the metal? Okay. Density is equal to mass per volume. So volume is going to be calculated by length into width into height. Okay, so volume for this rectangular block of metal would be PQ and R. Okay, so this option doesn't has R, so this can't be. This is the correct option. This option doesn't has R, and it has to divide it by it has to be divided by mass, and here also it should be a division sign. So A is the correct option. Okay. Which substance in the table has the lowest density? Okay. Again, density is equal to mass per volume. So we are going to use these values. For the first one, our mass is 1.2 and our volume is 1. So it would be 1.2 gram per centimeter cube. Okay, the other one is 1.5 grams per centimeter cube. For this one, we have 1.8 divided by 2, and this gives us 0.9 grams per centimeter cube. And here we have a density of 1 gram per centimeter cube. So out of all these values, B will have lowest density. Okay, the lowest density is C, 0.9 grams per centimeter cube. This was the lowest. 1.2, 1.5 and 1 all are higher than the value of olive oil. Okay, ji. A student carries out an experiment to find the density of the rock. I don't know why there are so many questions of density in this topic. This is a topic for weight and mass. I don't know why it keeps on coming up, but oh, okay, we will be solving them. Again, density is equal to mass per volume. So let's go through the question. Which two measurements does the student need to make to determine the density of the rock? Okay, we know that we need two values, and they are of mass and volume. Okay, so increase in mass and increase in volume of liquid. Okay, final mass, increase in depth of liquid. increase in mass, increase in depth of liquid, final mass, and increase in volume of liquid. Okay. So this water was already there. ठीक है जी. Now when we put in the rock, the level of the water rises. This means that the volume has risen, of the water has risen. So we have the weight over here, and the weight of cylinder plus the water before is also over here. ठीक है, तो अब हमें क्या करना चाहिए? ये जो बैलेंस अब वेट बता रहा, मास बता रहा है, दिस इज cylinder plus water plus rock. And in order to measure the density of the rock, we just need the mass of the rock. And we don't need the mass of cylinder and water. So we just need the measurement, which is increase in the mass. ठीक है? Increase in the mass would be subtracting the initial mass with the final mass. ठीक है? और हमें चाहिए होगा, obviously the volume has also increased, so subtracting this from this would give you the value of the volume over here. ठीक है? So if we just say that increase in the mass, we will require increase in the mass, as you have to subtract the masses of cylinder and water to get the mass of the rock. ठीक है? And then for the volume, we will need the increase in volume. ठीक है? And then we will be able to find the density of the rock. ठीक हो गया ना? Increase in mass भी हमें चाहिए था कि कितना increase हुआ है? 64 in this case. और हमें increase in the volume of liquid भी चाहिए था, so that we could subtract the final and initial volumes. ठीक है? And that is how we are going to reach over here. ठीक है जी? A measuring cylinder contains 40 centimeter cube of water. A stone of mass 94 grams is lowered into the water so that it is fully submerged, as shown. This is the rock. What is the density of the stone? Okay. To find the density, we need mass by volume. So we need mass of the rock and the volume of the rock as well. We already know what is the mass of the rock. ठीक है? It's 94 grams, and the units in the answer and the question are same, so we don't need to do anything else. Actually, the initial volume has been given, which is 40 centimeter cube. And after this rock has been dropped into it, the new volume is 70, 75, 76 centimeters cube. So to find the volume of the rock, we need to subtract 40 from 75, which gives us 36. So 94 over 36. This is our mass. This is our volume. Sorry, kgs में नहीं था, grams में था. So this is going to give us 2.611 grams per centimeter cube, and if we round off the answer, then we will get D as an answer. ठीक हो गया? The mass of an empty flask is 34 grams. The volume of liquid added to the flask is 20 centimeter cube. The total mass of the flask and the liquid are 50 grams. What is the density of the liquid? Okay, we now know that the flask when it was empty was 34 grams. ठीक है? When it was filled with liquid, its mass is 50 grams. ठीक है? और हमें पता है कि volume of the liquid is 20 centimeter cube. So we need to find the mass and volume of the liquid, ठीक है, to find the density of the liquid. So mass of the liquid we can find if we subtract the mass of the empty flask from the mass of the filled flask, ठीक है जी. The 50 minus 34 will be the mass of the liquid. 50 minus 34 gives you 16, yes, 16 grams. So this is the mass of the water or liquid, sorry. They haven't mentioned it's water. And mass हमारे पास है और liquid हमारे पास है already. So we will put these values in our formula, 16 over 20 centimeter cubes, and this would give us 0.8 grams per centimeter cube. So this is going to be our answer. Okay. A tank shown has the dimensions 5 into 4 meters into 4 meters. Okay. This is the tank. It is completely filled with water of density 1000 kgs per meter cube. What is the mass of water in the tank? Okay. So this is again a question to find density, mass per volume. So here we know the density of the liquid, okay, and we don't know the mass. That is, we have to find that out, okay, and volume we can find by the dimensions of this tank shown, because volume is the space occupied by the object, ठीक है. So volume can be 5 into 4 into 4, 20 and 20 into 4 would give you 80 centimeters, 80 meter cubes, meter cube. ठीक है जी. So now we have our density, which is 1000 kg per meter cube. We have to find the mass, and we now know the volume to be 80 meter cubes. So 1000 into 80 is going to, give you 80, 80,000 kgs to be the mass, okay, and it's our option D. Okay, moving on to the next question. A small bottle has a mass of 20 grams when it is empty. The volume of the bottle is 10 centimeters cube. When full of liquid, the total mass is 150 grams. What is the density of the liquid? Okay, to find the density of the liquid, we need mass and volume of the liquid. We already know that the volume of the bottle is 10 centimeter cubes. So the volume of the liquid when the bottle is filled, because they've given us the fact that the bottle is filled with liquid, it is full of it. So the mass of water, the volume of the water and the volume of the bottle would be the same. Okay, so we have our volume. We need to find our density, but in order to do so, we need to find the mass of the liquid. Okay, so we know that the empty bottle is 20 grams, and when it is filled with liquid, its mass becomes 150 grams. So the mass of the liquid would be this final value minus this initial value. So filled minus empty would give you the mass of the liquid. 150 minus 20 would give you 130 grams. ठीक हो क्या ना? So now we can put in our values. 130 by 10, and this gives us 13 grams per centimeter cubes. So option C is correct. A rectangular metal block is 20 centimeters long. The cross-sectional area of the block is 25 centimeters. The mass of the block is 4,000 grams. What is the density of the metal? Okay. Density, ठीक है जी, हमें mass और volume चाहिए of the metal, ठीक है, in order to find the density of the metal. We already know what is the mass. Mass is 400 grams. We don't know the volume. Okay, volume is found by length into width into height. We know that the cross-sectional area means length into width have already been multiplied, because area is equal to length into width, ठीक है ना, of a rectangle. The block you can see is a rectangular metal block, ठीक है. So we already know that the area has been taken out for us, which is this, ठीक है. So we can multiply 25 with the height, or obviously with the length, into 20, which is going to be 25 into 20 is 500. 500 would be it. So volume would be 500 centimeters cube. So putting in these values, mass is 4,000 grams, volume is 500. So it would be 8 grams per centimeter cube. C is our correct answer. Okay. A sphere P made up of steel has a weight of 10 newtons on Earth. Okay. Another sphere Q, also made of steel, has a weight of 10 newtons on Mars. The gravitational field strength on Earth is greater than the gravitational field strength on Mars. That we already know. Which statement is correct? Okay. The mass of sphere P is the same as the mass of the sphere Q. They haven't mentioned this anywhere. ठीक है? अच्छा चलो first see, we'll look at the options and then we'll find and discuss the answer. The mass of sphere P is less than the mass of sphere Q. On Mars, the weight of sphere P is more than 10 newtons. Okay. On Earth, the weight of sphere Q is less than 10 newtons. Okay. This question we can solve very easily. Okay. We know that the weight of sphere P is 10 on Earth. So we can easily find its mass. Okay. Because the answers have mass and weight. So we can just solve this question. Okay. For P, W is equal to mg would be, weight is 10, m, and we are taking the value to be 10. Okay. 10 divided by 10 is the mass. Okay. Actually, we know that this is on Mars and the gravitational field strength on Mars is less than that of the Earth. They've stated it over here as well. So for Q, W is equal to mg. We will take any value of g that is lesser than the value of g on Earth that we've taken as 10. We can take any value like that for that purpose. ठीक है ना? Okay. आप 5 ले लो, ठीक है. 10 by 5 would be the mass. 5 2s are. So we can see that the mass of P is not the same as mass of Q. ठीक हो गया? On Mars, the mass of sphere P is more than 10 newtons. You can always find it over here. We have taken the value of G as 5. Okay? If we solve it for P, W is equal to mg. W is equal to mass is 1 and 6. So we can see that the weight of P is not more than 10 on Mars. So this is also not correct. ठीक है, the mass of sphere P is less than the mass of the sphere Q. That we've already established. This is our correct answer. I've solved them for each of the scenarios, and on Earth, the weight of the um, sphere Q is less than 10 newtons. This also can't be. I've solved them for 3 of these cases, and we found out that for B, this is correct, that the mass of sphere P is less than the mass of sphere Q. ठीक है? So B is going to be our correct answer. Okay, question number 18. A metal ball is attached to a cork and is lowered into a measuring cylinder, pulling the cork into the water as shown. The mass of the cork is 4.8 grams. What is the density of the cork? Okay. We can see over here that this is the volume of water before any submersion took place. This is the change in the initial and final would give you the volume of this metal ball. And then all the three would be given by 80 centimeters cube. ठीक है ना? Okay. So the value in this one shows the volume of water and the ball, and this is the volume of water, ball and cork, and we are finding the density of the cork, so we would need mass and volume of the cork. ठीक है? तो mass has already been given to us, which is 4.8. To find the volume, we will simply subtract 56 from 80, because this gives you the mass, the volume of water plus the ball. ठीक है? And this one gives you the volume of water, ball and cork. So in order to find the mass of the cork, we have to subtract the volume of water and ball. So this is the volume of water and ball. So 80 centimeters cube minus 56 centimeters cube would be the volume of the cork. This is the cork. ठीक है जी? This gives us 25 centimeter cube. Okay, the 4.8 was the mass of the cork that was already given to us, and 24 centimeter cube is the volume of the cork that we've taken out. Okay, so dividing these two would give us 0.60 grams per centimeter cube. This is the option C. I hope you've understood the question. I think this topic also has a lot of questions. I think the total number of questions would be around 58. So we'll have to divide it in 2 parts as well. I think we have to divide it in 2 or 3 parts. So let's see where we cut off the first part of the video. अच्छा जी, question number 19. Question number 19 states that a square wooden raft floats on the lake. The density of the water in the lake is 1000 grams per meter cube. The sides of the raft are 2 meter long and the thickness of the raft is 0.2 meters. The mass of the raft has also been given. How many barrels, each of 100 kgs, could be placed on the raft before its surface sinks to the surface of the water. Okay, this is an interesting question. Okay, the density of the water has been given. Let's write our data first. To be 1000 kgs per meter cube. ठीक है? The volume of the raft, water. Let's not confuse it. Achha, now we are mentioning the volume of the raft that's been provided to us. 2 meters long है वो और thickness उसकी 0.20 है. इसका मतलब ये है कि if this is your raft, तो वो 2 meters लॉन्ग है और यहाँ से भी 2 है, यहाँ से भी 2 है और डेप्थ उसकी जो है वो 2 meters है. थिकनेस या डेप्थ या व्हाटएवर ऐसी है या ये ऐसी है. अभी मुझे 3D उसका बनाना नहीं आ रहा, तो ये उसकी थिकनेस है. ठीक है, ये थिकनेस है और 2 साइड्स उन्होंने दे दिए, तो वॉल्यूम निकालने के लिए ये तीनों वैल्यूज बहुत काफी हैं. So that would be 2 into 2 into 0.20 and that's going to give you 0.8 meter cube. ठीक है, and then we need the mass. Mass has already been given 700 kgs. अच्छा. So for this to happen, the density of the raft should be more than 1000. ठीक है ना? ऐसा ही है ना? It's floating on the lake, so the density of the water is given. So the density of the raft has to be more than that of the density of the water. Anything with less density floats above something that has more density. For example, oil has less density, so oil is going to float on the surface of water which has more density. Water ki density is more than that of oil, so oil is going to be floating on the top of it. So all this to happen, the density of the raft should be more than 1000. ठीक है ना? Should be more than that of the density of water. वरना वो float नहीं कर सकती, वो sink कर जाती. ठीक है? तो density हम निकाल लेते हैं raft की. Mass per volume. Mass उसका given है 700, volume हमने निकाल ली है 0.8. ठीक है, तो आंसर would be 875 kg per meter cube. ठीक हो गया? ये हमने निकाल लिया. अब वो दूसरा पार्ट जो कहता है ना क्वेश्चन का, वो ये है कि कितने बैरल्स, how many barrels each of mass 100 kgs could be placed on the raft before its surface sinks to the water. अब for this to happen ना, कि raft जो है वो sink कर जाए, उसकी density जो है वो इससे ज्यादा हो जानी चाहिए, फिर ही वो sink करेगा ना. फ्लोट वो तब करेगा जब उसकी डेंसिटी कम होगी फ्रॉम दैट ऑफ द डेंसिटी ऑफ वाटर. ठीक है, और सिंक वो तब करेगा जब उसकी डेंसिटी जो है वो ज्यादा हो जाएगी फ्रॉम दैट ऑफ वाटर. ठीक है, तो अगर फॉर एग्जांपल 100 kgs के हम एक बैरल यूज करें तो फिर क्या होता है. ठीक है, हम यहाँ पे स्पेस ले लेते हैं और फिर हम रब कर देंगे. D is equal to M over V. The mass was 700, ठीक है, of the raft. अगर हम इसमें 100 grams का एक बैरल ऐड कर दें तो the mass would be 800. ठीक है, divided by volume is not going to change. So 800 by 0.8 अगर हम करें तो वॉल्यूम आ जाएगी 1000 kgs per centimeter क्यूब आ जाएगी. अब देखो कि उन दोनों का जो डेंसिटी है वो तो सेम हो गई, तो अब इसको राफ्ट को सिंक करना पड़ेगा इनटू वाटर. ठीक है, तो अगर हम एक बैरल ऐड करें, उसका वेट 700 से 800 हो जाए, तो उसकी डेंसिटी वुड बिकम इक्वल टू द डेंसिटी ऑफ द वाटर and it is going to sink. टू ऑब्जेक्ट्स जिनकी डेंसिटी सेम हो वो एक दूसरे के ऊपर फ्लोट नहीं कर सकती. अगर आप पानी एक ग्लास में लो और उस ग्लास में और पानी डाल दो तो आपको कभी भी पता नहीं चलेगा कि कौन सा पानी आपने बाद में डाला था और कौन सा पानी आपने पहले डाला था. जैसे ऑयल की डेंसिटी कम थी तो वो आपको ऊपर फ्लोट करता हुआ पानी पे नजर आ रहा था. अगर फॉर एग्जाम्पल ऑयल और वाटर की डेंसिटी दोनों की सेम हो जाए तो ऑयल इज नॉट गोइंग टू फ्लोट. Oil is not going to float and it will also get merged with water. So जब दोनों की डेंसिटी सेम हो गई raft की भी और water की भी तो अब raft can't keep on floating on water and it is going to sink. ठीक है, समझ आ गया. आपके दिमाग में ये आ रहा कि अभी तो डेंसिटी सेम हुई है, एक बैरल और डाल देते हैं तो आंसर आ जाएगा. वैसे तो 2 की ऑप्शन नहीं है, 7, 8 और 15 तो बहुत ही ज्यादा हो जाएंगे, तो 1 सबसे सूटेबल ऑप्शन वैसे भी लग रहा है. लेकिन आपके दिमाग में आ रहा हो अगर कि भाई हम ऐसे कर देते हैं कि 2 बैरल्स क्यों नहीं डाल के देख लेते, तो वो इसलिए नहीं डाल के देख लेते क्योंकि वो तो डेंसिटी जब ज्यादा हो, जब इक्वली हो गई है तभी वो राफ्ट फ्लोट नहीं कर सकता, तो ज्यादा करने का तो जरूरत ही नहीं है. गेट द आइडिया? सॉरी, मूविंग बैक. इस क्वेश्चन के लिए हम जगह क्लियर कर लें प्लीज, क्योंकि आई होप यू गॉट अ होल्ड ऑफ द क्वेश्चन नंबर 19. थोड़ा डिफरेंट क्वेश्चन था, थोड़ा हट के था, वरना तो वही क्वेश्चंस आए जा रहे हैं. मैस अर्थ पे इतना है, मार्स पे इतना है, किसका मैस चेंज हो जाएगा, किसका वेट चेंज हो जाएगा. तो मेरा ख्याल से ये जरा डिफरेंट क्वेश्चन था. फ्रॉम दैट आई होप यू अंडरस्टूड द आंसर. 4 students make statements about mass of the object. Which statement is correct? The mass of an object depends on the gravitational field strength which acts on the object. No, weight of the object depends upon the gravitational field strength which acts on the object. The mass of the object divided by its weight is equal to acceleration with which it falls freely. Yeah, W is equal to mg होता है ना, तो W by m would be this. So no, the weight of the object divided by mass is equal to the acceleration with which it falls freely. The mass of an object increases when the temperature of the object increases. Mass का temperature से कोई ताल्लुक नहीं है. D is the correct answer, which states that the mass of an object resists change in motion of the object. ये question आ जाए और mass के साथ इसको relate करना हो, तो this is the only answer that matters. ठीक है? Okay, I think we'll do 30 questions now and then 30, almost 28 questions would be left for later. वीडियो तो अभी हम 30 कर लेते हैं ताकि आधे आधे पार्ट्स, आधे आधे क्वेश्चन 2 पार्ट्स की वीडियोस में डिवाइड हो जाए. ओके ओके, क्वेश्चन नंबर 21 states that a body is moved from place X to place Y where the gravitational field strength is different. Okay, what happens to its mass and the weight due to the move? Okay, we already know that mass does not change anywhere. ठीक है? Because mass does not depend on the gravitational field strength. ठीक है? Weight depends on the value of that. ठीक है? Mass, irrespective of the gravitational field strength value, would remain the same. Mass would be the same on Earth and mass would be the same on Moon where the gravitational field strengths are different. ठीक है? तो mass is not going to change, it would stay the same. तो हम इस दोनों आंसर्स को तो एलिमिनेट कर लेते हैं. वेट का हम देख लेते हैं कि उसका क्या होता है. वेट का हमको पता है कि वेट जो है वो डिपेंड करता है ऑन ग्रेविटी, ऑन द वैल्यू ऑफ ग्रेविटेशनल फील्ड स्ट्रेंथ, वैल्यू ऑफ g. तो the weight is going to change. ठीक है? It won't remain the same. So C won't be the answer and D will be. ठीक है? D is correct. Okay. Question number 22 states that please. A brass ball and a feather are released at the same time. On Earth, the ball reaches the ground first. On Moon, they reach the ground at the same time. What is the explanation for this? Okay, now we've done this question many times that a ball and a feather are going to reach at the same time when the air resistance is ignored. ठीक है, और मून पे वो सेम टाइम पे इसलिए पहुंचेंगे क्योंकि वहां पे कोई एटमॉस्फेयर प्रेजेंट ही नहीं है, एयर नहीं है, तो एयर रेजिस्टेंस भी नहीं है। ठीक हो गया ना? ये तब होता है अर्थ पे। आप कहोगे पीछे तो हम कर रहे थे और आप हमें समझा रही थी कि ये दोनों सेम टाइम पे पहुंचेंगे अगर सेम टाइम पे छोड़े गए। यस, वो उस केस में जब आपको साथ मेंशन किया गया होगा कि एयर रेजिस्टेंस इज निग्लिजिबल। ठीक हो गया? तो अब अगर हमें ये करना है कि अर्थ पे हैं हम और एयर रेजिस्टेंस इज बीइंग टेकन इनटू अकाउंट, तो पहले क्यों पहुंचेगा वहां पे मून पे इकट्ठे क्यों पहुंचेगा और अर्थ पे क्यों नहीं पहुंचेगा, उसकी सिंपल और स्ट्रेट फॉरवर्ड एक्सप्लेनेशन ये है कि देयर इज नो एयर रेजिस्टेंस ऑन द मून। ये जो मैंने आपको बताया कि उसके पास एटमॉस्फेयर ही नहीं है, उसके पास एयर ही नहीं है, तो देयर वोंट बी एनी एयर रेजिस्टेंस प्रेजेंट और वो एक साथ पहुंच जाएंगे। ठीक है? 24. The gravitational field strength on moon is less than that of the earth. ये तो मेरे ख्याल से इतनी दफा क्वेश्चन आएगा कि आपको रट जाएगा कि मून पर ग्रेविटेशनल फील्ड स्ट्रेंथ और मार्स पे ग्रेविटेशनल फील्ड स्ट्रेंथ अर्थ से कम है। ठीक है, जब वो नहीं भी मेंशन कर रहे होंगे ना तो भी आपके दिमाग में ये बेल्स की तरह बजेगा। Which of these is different when done on moon as compared to when it is done on earth? Okay, the gravitational potential energy gained by a stone lifted through the same vertical height. Okay, the kinetic energy gained by a ball when hit with the same force for the same period of time. The momentum gained by a bullet when fired from the gun. The work done in accelerating a stone from rest to the same speed. अच्छा, अब आपको पता है कि ग्रेविटेशनल पोटेंशियल एनर्जी आपको आगे जाके वर्क वाले चैप्टर में वर्क प्रेशर फोर्स वाले में ये पढ़ोगे भी, और मैं भी अभी बता देती हूँ कि जो ग्रेविटेशनल पोटेंशियल एनर्जी होती है उसका फॉर्मूला होता है मास इनटू ग्रेविटेशनल फोर्स बीइंग अप्लाइड एंड हाइट। ठीक है, तो इसके अंदर आप देखो कि जी की वैल्यू आ रही है। ठीक है, सो जब जी की वैल्यू में कोई चेंज आएगा तो फिर जरूर होगा कि मून पे और अर्थ पे ये वैल्यूज डिफरेंट डिफरेंट आएंगी बिकॉज ऑफ द चेंज इन वैल्यू ऑफ जी। ठीक है ना? तो ये सही है, लेकिन हम बाकी भी देख लेते हैं। काइनेटिक एनर्जी गेन बाय बॉल, अच्छा काइनेटिक एनर्जी जो है उसका फॉर्मूला होता है हाफ एम वी स्क्वायर। आपको पता है मैस जो है वो मून पे भी सेम होगा, अर्थ पे भी सेम होगा, तो इस वजह से दिस इज नॉट गोइंग टू मैटर एट ऑल। अच्छा, मोमेंटम जो है वो डेल्टा वी ओवर टी होता है, वेलोसिटी ओवर टाइम। सो वेलोसिटी का भी कोई लेना देना नहीं है ऑन मून एंड अर्थ। ठीक है, तो ये भी कुछ प्रॉब्लम नहीं क्रिएट करेगा। वर्क डन इज फोर्स इनटू डिस्टेंस, तो फोर्स इनटू डिस्टेंस भी कोई वर्क प्ले रोल प्ले नहीं कर रहा इस केस में, जहां पे आपको देखना है कि which is of these is different। तो काइनेटिक एनर्जी, मोमेंटम और वर्क डन तीनों जो है वो मून पे और अर्थ पे सेम रहेंगे बिकॉज दे डोंट इन्वॉल्व दिस जी। The value of the g is only involved in gravitational potential energy gained। ठीक है, क्योंकि अर्थ पे ज्यादा है तो अर्थ की ग्रेविटेशनल पोटेंशियल एनर्जी के अगेंस्ट जब आप जाएंगे तो ज्यादा एनर्जी गेन करेंगे, और मून पे चूंकि कम है तो जब मून पे कोई भी चीज को रेस करेंगे वहां पे क्योंकि ग्रेविटेशनल पोटेंशियल एनर्जी कम है तो इसलिए ग्रेविटेशनल फील्ड स्ट्रेंथ की वैल्यू कम है, तो ग्रेविटेशनल पोटेंशियल एनर्जी की वैल्यू भी कम होगी। ठीक है, I hope I've explained enough. 24. A helium balloon is tied on top pan. The metal block of mass 100 grams is placed on the balance. The reading on the balance is 91 grams. Okay. Which statement can be deduced from this experiment? Okay, the balloon exerts a downward force of 0.09 Newton on the top pan में. बेटा हीलियम बलून तो इतना बेचारा सा है, लाइट वेट सा है, वो कहाँ डाउनवर्ड फोर्स एक्सर्ट करेगा? तो नो, दिस इज नॉट द आंसर. द हीलियम हैज अ मास ऑफ -9 ग्राम्स. नहीं बेटे, हीलियम का मास -9 ग्राम नहीं है. हीलियम हैज अ मास ऑफ +9 ग्राम्स. नहीं, यहाँ पे 91 ग्राम्स आना जो है वैल्यू 100 ग्राम्स ब्लॉक की, वो इसलिए है क्योंकि रिजल्टेंट डाउनवर्ड फोर्स ऑन द टॉप बैलेंस इज 0.91 न्यूटन. इस वजह से ये ऐसा है. हीलियम का वेट मास का कोई लेना देना नहीं है इसके साथ, और बलून भी डाउनवर्ड फोर्स एक्सर्ट नहीं कर रहा. ये रिजल्टेंट डाउनवर्ड फोर्स ऑन द टॉप पैन बैलेंस है, जिसकी वजह से ये जो है ना 0.91 न्यूटन आ रहा है इंस्टेड ऑफ 100 ग्राम्स. ठीक है, और वो आप देख लो ना W is equal to mg करके, तो उससे भी आपको आइडिया हो जाएगा. ठीक हो गया? Okay, moving forward to question number 25. Which statement about the mass and weight of an object is correct? They are both affected by changes in acceleration of free fall. Acha, they are both forces. They have different units. They are both forces भी नहीं होगा. They are both affected ये भी नहीं होगा. Yes, their units are different. एक को मैयर किया जाता है kgs में, एक को मैयर किया जाता है न्यूटन में. वेट जो है वो फोर्स है, मास जो है वो फोर्स नहीं है. वेट इज कैलकुलेटिंग बाय डिवाइडिंग मास by acceleration of free fall. No, weight is calculated by multiplying mass with acceleration of free fall. So C is the correct answer. Okay ji, question number 26. Which statement about mass of the object is correct? Mass is equal to the density divided by the volume. देख लेते हैं जी. No, it is equal to density multiplied by the volume. So ये correct नहीं है. It is equal to the weight multiplied by the gravitational field strength. नहीं जी. Weight over gravitational field strength is equal to mass. So it's divided by, not multiplied by. It is the effect of gravitational field on the object. No. Weight is the effect of gravitational field on an object. So D would be the answer. It is the property that resists the change in velocity. Yes, this is the answer. It resists the change in which direction it's moving. Okay. (27th). Okay, shows the beam balance. A beaker with a wire loop balances the standard masses. Beaker with a wire loop attached to it is balancing the standard masses. The beaker is then removed and hung from a spring. The spring extends by 5 centimeters as in diagram. Okay. The experiment is repeated with the same apparatus on moon, where the acceleration of the free fall is less than that of the earth. Which statement describe what happens on the moon? अच्छा जी देखो ना, mass जो है ना वो तो change होना नहीं है, तो diagram 1 जो है और जो वो उसका आंसर सेम रहेगा. और चूंकि ये जो स्प्रिंग बैलेंस है ये वेट के साथ और फोर्स के साथ एसोसिएटेड होता है, तो इस वजह से ये चेंज होगा. बाहर हम आंसर्स पढ़ लेते हैं. द बीम बैलेंस इज बैलेंस्ड and the spring balance extends by 5 centimeter. Okay. The beam balance is balanced and the spring extends by less than 5 centimeter. Okay. The right hand balance pan is higher and the spring extends by ये. अच्छा, अब कोई भी चेंज जो इस में आ रहा है बीम बैलेंस में, ये तो irrelevant होगा क्योंकि हमें पता है कि मास जो है वो irrespective of the value of g जो है जो कि मून और अर्थ पे डिफरेंट है, सेम रहेगा. वो मून पे भी सेम रहेगा, वो अर्थ पे भी सेम रहेगा, तो ये दोनों तो एलिमिनेट हो जाएंगे. हाँ जी, जो बाकी है उसका हम देख लेते हैं कि क्या है. तो द बीम बैलेंस इज बैलेंस्ड एंड द स्प्रिंग एक्सटेंड्स बाय 5 सेंटीमीटर। क्योंकि वहां मून पे डिफरेंट होगा तो ये सेम नहीं हो सकता कि वो अर्थ पे भी 5 सेंटीमीटर ही एक्सटेंड हो रहा है और मून पे जाके भी 5 सेंटीमीटर एक्सटेंड ही हो रहा है। तो ये सही आंसर है कि the beam balance is balanced and the spring extends by less than 5 centimeter because the value of G on the moon is less than that value on earth. ठीक है। 28th, an object always has mass but does not always has weight. What must be present and acting on the mass for it to have weight? Okay. वेट का सारा ताल्लुक जो है हम अभी पढ़ते आ रहे हैं कि ग्रेविटेशनल फील्ड स्ट्रेंथ से है। सो ए इज गोइंग टू बी द आंसर। द सेट ऑफ स्केल्स नहीं हो सकता। डिस्प्लेस्ड वाटर का कोई ताल्लुक नहीं है। फ्रिक्शन ड्यू टू एयर रेजिस्टेंस फ्री फॉल पे एक्ट कर रही होती है। मैस और वेट का इसके साथ कोई लेना देना फिलहाल नहीं है। तो ग्रेविटेशनल फील्ड होनी चाहिए, उसकी कोई वैल्यू होनी चाहिए, फिर ऑब्जेक्ट ऑफ एनी मैस इज गोइंग टू हैव अ वेट। अगर हम इसको यहाँ सॉल्व करके देखें द इक्वेशन दैट को रिलेट्स वेट एंड मैस और हम करें कि जी की वैल्यू 0 ले लें तो मैस कुछ भी हो वेट उस ऑब्जेक्ट का 0 ही आएगा। एनीथिंग मल्टीप्लाइड बाय 0 वुड बी 0। ठीक है ना। इन ऑर्डर फॉर समथिंग टू हैव वेट इट शुड हैव अ वैल्यू ऑफ जी। ठीक है। ग्रेविटेशनल फील्ड का होना बहुत जरूरी है। ठीक हो गया जी। 29th, a person steps on a bathroom scale. The bathroom scales records both mass and weight. Which row shows the reading on the scales? अब देखो mass जो है ना वो आपका न्यूटन्स में मेजर नहीं होगा। mass आपका weight सॉरी केजीज में मेजर होगा। तो ये वाला ऑप्शन तो आपका कट गया। ठीक है। ये वाला ऑप्शन भी कट गया। ठीक है। तो इन दोनों को हम चेक कर लेते हैं। W इज इक्वल टू mg। अगर हमारा मैस जो है वो 60 है, इसको 10 ही ले लेते हैं, तो हमारा वेट क्या होगा? सिक्स 600 हो जाएगा, है ना। तो 60 अगर आपका मैस हो तो 600 न्यूटन्स ही आपका वेट होगा। ठीक है। तो बी इज द करेक्ट आंसर। हमेशा इसको सॉल्व करके प्लीज देख लिया करो, इतनी ज्यादा देर नहीं लगती। W इज इक्वल टू mg आपका फॉर्मूला है। अगर यहाँ पे आपने 60 डाली, आप यू कैन ऑल्सो वर्क द अदर वे राउंड कि आपने जी यहाँ कर लिया है और आप मैस ढूंढ रहे हैं। तो 600 बाय 10 अगर आप करें तो आपके पास मैस आ जाएगा 60 kgs। सो यू कैन गो मतलब the other way round as well। ठीक है। तो हमने ये दोनों जाके चेक कर लिया और हमें पता चल गया कि 60 और 600 न्यूटन्स को रिलेट करेंगे। अगर मैस 60 होगा तो वेट 600 न्यूटन्स होगा। ठीक हो क्या जी। आई थिंक दिस इज गोइंग टू बी आवर लास्ट क्वेश्चन और इंशाल्लाह बाकी के क्वेश्चंस हम पार्ट बी में कवर करेंगे। So the last question for this video states that an object has a weight of 7600 newtons in a gravitational field strength of 100 newtons per kg. What is the mass of the object? Okay, हमें पता है mass और weight correlate होते हैं with this formula। हमें पता है कि जी उस चीज का weight 7600 newtons है और gravitational field strength की value 100 न्यूटन्स पर केजी है। तो मास फाइंड करने के लिए 7600 डिवाइडेड बाय 100 होगा और 76 केजीज आपका वेट आ जाएगा, विच इज ऑप्शन ए इन दिस केस। ठीक हो गया जी। सो इंशाल्लाह सी यू in the next part of the video, and if you found any of my answers and explanations helpful, so please remember me in your prayers. Hitting the bell icon, like button, subscribe button is very important, but remembering me in your prayers is also very important. Okay, so see you guys in the next video. Thanks for watching. Allah Hafiz.